find g of -2. So first we're going to rewrite it. Same thing as g of f of -2. Okay, so first we got to find f of -2. So f of -2 is equal to -2 minus 5. What's -2 minus 5?
-7.
-7. I should write that cleaner. Okay, so then I'm going to plop that in here. So we have g of f of -2. Well, that's really the same thing as, line here. That's the same thing as g of -7, because f of -2 is -7. So that's equal to, what's my g? It's whatever x is to the third power. So here we've got -7 to the third power. What's -7 to the third power? -343, I think you folks have.
Yeah.
So our final answer is g of f of -2 is -343. Next question is, now we're not doing a number, we're just putting the whole function in, which is kind of easier in some ways. We want g of f of x. So I'm going to take a shot at first rewrite it, that whole g of, easier way. And then there isn't a number. So f of x is just whatever f of x is. Up above, f of x was x minus 5. Or you know what, I'll do this. I'll do, do you want me to do an example? Yes or no? Mm-hmm. Okay. So I'll do from above, from this one, I'll do f of g of x from 35. So f of g of x is f of g of x. What's g of x? X to the third. So that becomes f of g of x. G of x is x to the third, so I'll put that in for g of x, since that's what g of x is. So then everywhere I see x, when I do the f of x, I'm going to put in x to the third. So my final answer will be x to the third minus 5. That's my f of g of x. So did folks see what I did? First rewrite it, f of, parentheses, g of x. So then what's g of x? Whatever g of x is, grab it, throw it in there. G of x is x to the third power, so it becomes f of x to the third power. So then in my function, everywhere I see x, I'm just going to put x to the third power instead. And then since there's nothing acting on the parentheses, it's not being raised to any power here or being multiplied in there, I can just take the parentheses away. Okay, so you folks do 36. But you'll have some bits and pieces. It won't be as clean. Here, I'll show you what I mean. If I'd done, if I had done g of f of x, then that would be g of f of x. What's f of x? F of x was x minus 5. F of x. So this becomes g of x minus 5. So that becomes whatever this is to the third power. X minus 6. X minus 5. But actually, then I would just stop you there, because I don't expect you to cube this, to cube it out. I would just have you leave it there. So g of f of x is equal to x minus 5 to the third power. Done. All right, so find yours. Do, like I said, you're just doing B. G f of x. Oh, make it only 4 points. We'll see. Okay, so g of f of x. So g of f of x. Is everyone good with at least rewriting it from here down to this spot here?
Yeah.
Yeah.
Okay, good. Now, what goes up? What's on the inside? F of x. What's f of x?
One.
Yeah, f of x is, so f of x is a 6. Everyone see the equal sign here? Everyone look up. Someone see the equal sign here? That means that this is the same thing as that. Anytime I can write f of x, I can instead write x cubed minus 5. They're the same, they're equal. So here, instead of writing f of x, I'm going to write x cubed minus 5. So how functions work? Everywhere you see g of whatever's inside, everywhere, anytime you see x, you're going to write that instead. So cube root of, I see an x, I'm going to put a giant parentheses. So again, if you had gotten to that habit in the beginning, I think Fox was really good about getting to that habit of every time you see an x, you put a giant parentheses. Whatever goes here, goes in there. That will make things so much easier. Okay. Is there anything acting on these parentheses inside here? Is it being multiplied in front, or is it being raised to a power?
No.
Yep, so I can take them away. Cube root of x to the third minus 5 plus 5. Combine like terms. If I combine like terms, what do I get?
Alpha to the
And you get 0. Those go away, right? So that stays x.
cube rooting with something that's being cubed, so it goes to become x.
Yep. And remember, the cube root of x cubed is just x. Now, for extra credit, I should ask you, what do the answers in part A and B tell you about the functions f and g? When f of g of x and g of f of x are x, then they are inverses of one another. They undo each other. Yeah, exactly. They are inverses. If it's not equal to x, then that would tell you that they're not inverses of each other. Right? So in other words, here, since g of f of x, this is not equal to x, neither of these is equal to x, these two functions, f and g, are not inverses of each other. All right, let's take a look at This is the last problem we'll cover today. The water tank. Okay, so before we do that, I want to just flip through this problem. Look at this problem, 41. Read it. Water tank is being emptied by a pump that removes water at a constant rate. After 2 hours, it contains 4,500 gallons of water. After 5 hours, the tank contains 2,250 gallons of water. Write a linear function, y equals mx plus b, that models the amount of water in the tank. What kind of problem is that, and how do I know? Linear. How do I know it's linear?
What it says.
It says, write a linear function. It's linear. Okay, let's look at the next one. What kind of problem is this? Look, read D. Again, it's linear. Okay, let's look at the next page. About 44. Doesn't say linear. Doesn't say growing or decreasing by a percent. Doesn't say exponential. So this is a regular proportion. Doesn't say anything. Does anyone kind of follow that? Proportion's the one that kind of doesn't really say anything. How about number 45? What kind of problem is that? Yep, direct. It varies directly. That's a direct variation problem. Does everyone see that? Okay, next one.
Inverse variation.
Yeah, it varies inversely. Everybody see that one? How about 47? Yeah, so it says quadratic function. Does everyone see that? That's going to be quadratic. Everybody following that? So incidentally, quadratic, that's where you're going to have that, the vertex is h comma k, where h is equal to negative b over 2a. I will give you vertex, negative p. I'll probably give something like that. I'll give you this part here. These two pieces here. Does that make sense on the exam? I won't tell you they go with quadratic, but you should remember that quadratic has a vertex. What about this one? 48. This one's a little bit harder. Yeah, it doesn't say exponential, but it does say it grows at a rate. So the rate, there's a rate of growth. Does everyone understand that?
Yeah.
Which means that we're going to have a factor. The factor will be 100%. It's growing, so plus 5.1%. So it's 1.051. We need to change it to decimal. Okay. I think that's the last one. Is that the last one? Yeah. Okay. So let's go back to this linear one. 41. So there's some things you need to know. You need to find your slope, right? the rate of change.
And the slope.
That's the same thing. Slope is the rate of change. And the b is your initial amount. So first, figure out what are the two things that vary in this problem. What are the two things that vary in this problem? Hours and gallons. Everybody on board with that part? So we have 2 points. My first point is going to match up with these guys. After 2 hours, 4,500 gallons of water. And then there's a second point. 5 hours, there's 2,250 gallons. Oh, I didn't give you the initial amount. Oh, well, that's kind of mean of me. Okay, but you have 2 points. Your first point is going to be time is typically Rx, almost always. So everybody all on board with that and got that sorted out? So it's going to be 2, 4,500. This other point is going to be 5, 2,250. So first, we need to find our slope. So remember how to find the slope? It's been a while. I guess I should show you. Yeah. So slope is, which is m, is rise over run. Also the y2 minus y1 over x2 minus x1. So the way I like to do this is I like to write the points out. Doesn't matter which one you do first, as long as you have them both in there. And then the y's are on top. I subtract them on top. And then I do the x's down below. So here I'm going to have 2,250 minus 4,500 over 5 minus 2. And I think we end up with negative 750. I recall, just remembering. And then I got to plug that. So now I have my. So now I know my slope. So now we have y equals negative 750 x plus b. I need to figure out what b is. So I can take either one of these points and substitute the x and y in for here to solve for b. Does everybody go with how we found the slope? Ooh, and I might ask you to interpret the slope. What does this mean in the context of the problem? What does this mean? Negative 750. What does that mean? What did you think?
Water you're losing an hour?
Yeah, you lose 750 gallons of water every hour. Write that better. Every hour. Okay, so I'm going to pick one of these points to substitute in for here. So I'm going to pick the first point. So I'm going to put the 2 in for. Put in. I have 2, 4,500. Put the 2 in for x. Put the 4,500 in for y. So then we end up with 4,500 equals negative 750 times x, which is 2 plus b. And I can solve for b. That ends up being 4,500 equals negative 1,500 plus b. Add 1,500 to both sides, and my b is 6,000. So now I have my final equation, which is y equals negative 750x plus b, which is 6,000. And again, you should have y equals something with x in it. All right, so we're done for today. On Wednesday, we might go over the rest of this problem, and then we're gonna kind of tackle the quadratics, refresh your minds on the quadratics, right? You know, how to find the vertex, min, max, that sort of thing. And any questions about these you want to go over, and then we can also talk about this, if there's anything from exam 3 that you're like, we need to go over some of those.
Can you record it so we can